Integrated 2, Chapter 7, Day 6. So obviously it's been a while since we've done flowcharts, but this is where they introduce proofs. So obviously we've sort of introduced proofs, but you kind of get a feel for what they're asking you to do anyway, and I still think it's a good proof. So we're going to go through it and just sort of ignore the flowchart part. But it says, Ansel has done a lot of proofs using congruent triangles. Now he wants to challenge himself to prove the conjecture that opposite angles of a parallelogram are congruent, but to prove it without using congruent triangles. So he knows he could use congruent triangles in CPCTC pretty easily, but instead he wants to do it a different way. So here is what is given, and as always I would ask you and encourage you to pause the video and see how much of this you can come up with in your own. I will tell you that steps 2 and 3 sort of combine, but anyway. So hopefully you paused it and have done it for yourself, and let's go ahead and take a look. So first of all, we know that TUVW is a parallelogram, and that is given. So next it says something is true because the definition of a parallelogram. Well, if you know what's true is that the opposite sides are parallel. So the next one says that TU and WV are parallel. So step 2 must be TW is parallel to UV. And so I will say that TW is parallel to UV. I know that because that's the definition of a parallelogram, and I know that TU is parallel to WV. Again, that is the definition of a parallelogram. Next, they're saying that angle B and angle C are the same. Well, why would angle B and angle C be the same? It looks like if lines are parallel, which they are. So if lines parallel, then those appear to be corresponding angles are congruent. I apologize for my handwriting. If you look at the next one, it says if lines are parallel, then the alternate interior angles are congruent. Well, that must be angle A and B. So angle A is congruent to angle B, because if lines are parallel, then alternate interior angles are congruent. And then now what we can say is angle A is congruent to angle C, either because of transitive or because of substitution, but I think our book is kind of ignoring transitive, so we're going straight with substitution. Hey, look, if B equals C and A equals B, then I can just sort of substitute out the B with the C, and now I know that the opposite sides, or the opposite angles of a parallelogram, are indeed congruent. I'm going to go ahead and pause here and set up the next proof. Okay, so the next one. A line is a perpendicular bisector of a line segment if the line is perpendicular to the segment and passes through the midpoint of the segment. So that means it has to be perpendicular as in 90-degree angles and has to bisect as in cut in half. So it says if in the figure at right, PM is the perpendicular bisector of AB. Point M lies on AB. So it says copy and complete the 2-column proof to show that P is equidistant, the same distance from A and B. That is proof PA is congruent to PB. One thing I would say here is I feel like this proof could use another step where you draw auxiliary lines. So hopefully you guys pause the video and try that. But again, I think right after the third step, I would draw auxiliary lines and then sort of see how you end up at that point. All right, so hopefully you did. And it says PM is the perpendicular bisector of AB. I know that because it's given. Now, something is true because it's perpendicular. Well, I think that would be these are 90-degree angles. So I'm going to say angle PMA is congruent to angle PMB, and that's congruent to 90 degrees, and that's the definition of perpendicular. Next, definition of bisector. Well, that means cut in half, and again, I know PM cut this in half, so I'm going to say AM is congruent to MB. AM is congruent to MB. That's the definition of a bisector. I said I would draw some auxiliary lines. I think this would be a good place for it. So I'm going to draw auxiliary lines PA and PB. Hopefully that makes sense right there, and that would, I think the book just is lazy and takes shortcuts, and I think that's one of the ones it did. So now I will keep going. I will say that PM is congruent to PM. I know that because of reflexive. I will say, this looks really sloppy right here, so let me clean this up a little bit. Boy, the eraser is so small. Alright, let's see if I can draw a straight line. Oh. There we go. And now I'm going to say these triangles are congruent. So I will say triangle PAM is congruent to triangle PBM. And I know that's true because of side angle side. And then this is a fancy way of saying CPCTC. Congruent triangles have congruent parts, or corresponding parts of congruent triangles are congruent. So we need to say something is true. Well, I'm trying to prove PA is congruent to PB, so I think I'll say that here. PA is congruent to PB because of CPCTC. Alright, let me pause and set up the last of the proofs. There's a couple more, I think. To do here is prove that these triangles are congruent, and I'll tell you there's several different ways that we can do this proof. This is just going to be one of them, so I don't want you to feel like if you did it a different way you're necessarily wrong. You could definitely be correct. So actually I guess I'll put it down here. I feel like I'm sort of tight on space here. So I'll say C is the midpoint of BD. I know that because it's given. But who cares? Like, why did they tell me that? And again, if they tell you something in the given, it's probably going to be used as evidence. Well, if C is the midpoint of BD, then I can say BC is congruent to CD, because that's the definition of a midpoint. That's the entire reason they told me that. And again, I know midpoints and bisectors are really similar, but make sure you understand that there is a difference between the two. Actually, a bisected side and a midpoint are very, very similar, but just make sure that you use the correct vocabulary depending on what the problem gave you. Anyway, so at this point here, I know that AB is parallel to DE. Again, that's given. It's given by ticks. I can say ticks are given. Now, the reason that they tell me lines are parallel is because I am going to use angle relationships. Well, I could say angle A is congruent to angle E, and I can say angle B is congruent to angle D. And the reason why I can say all that is because of if lines are parallel, which they are, then alternate interior angles are congruent. Now think about it. I ignored the obvious vertical angles right here. So if you wanted to do vertical angles there, you could have, and at that point you could have done angle side angle or angle angle side. I just ended up proving angle angle side. But the long story short is I can now say that triangle ABC is congruent to triangle, and again, A goes with E, B goes with D, and C goes with C, and I proved it because of angle angle side. Again, you could have done this proof using angle side angle, or even angle angle side, but using these vertical angles if you wanted. There's nothing wrong with that at all. Alright, so the next one here, it says I need to prove that these triangles are congruent. So it says that GH is congruent to MN. Okay, so I am going to say that GH is congruent to MN I know that's true because it's given. I'm going to say that GK is congruent to MP. I know that that's given. I'm going to say that angle K is congruent to angle P is congruent to 90 degrees, because that is given. And now it looks like I have hypotenuse leg, right? So I can say I proved the hypotenuse is the same, I proved the leg is the same, and I prove I have a 90-degree angle. So that's what I need to prove for hypotenuse leg. So I'll say triangle GKH is congruent to triangle. So let's see, G and M would appear to go together. K and P would definitely go together. And H is across from 1 and N is across from 1. And I'll say that's true because I have hypotenuse leg congruence. So hopefully you guys are pausing these videos and trying them for yourself and doing okay.